What we'd like to do now is spend a little bit of time looking over the different classes that we've written to support the user interface that we just finished speaking about. The first one that we're going to look at is the rules class, because that's the one that really dictates how we're going to play this particular game. So what we're doing is I've followed my normal convention of prefacing the class name with CLS, and the only reason again is because when you see a list of classes then under IntelliSense, it presents them with all of them grouped together rather than scattered all over the place. I think it's a good habit to get into and one that'll actually save you time in the long run. The symbolic constants that I use, a tie, dealer wins, player wins, those are just to make the code a little easier to read. Here again we have the instance members or the properties. You'll see these called instance members. You'll see them called properties. We've used properties throughout, but you'll also see them called attributes in other languages. All of them were given the private access specifier. And again, the reason is because we want to hide all of those particular properties from the outside world. We also have an instance of the card deck that we're going to be using for our rules. So we've put that in as a private data item as well. The constructor, we haven't overridden the constructor in the sense of passing in any information from the outside world, but we have made sure that we initialize the balance property and the wager property to their appropriate values, and we've also initialized and instantiated the myDeck object. Recall up here, all this does is give us a pointer, a 4-byte pointer named myDeck. This piece of code down here is what fills that in with an L value that actually points to where all of the data are stored. So we've made that as part of the constructor so that when we come out of this, we have those balances set and we also have a real deck object to work with. The property methods, again, they're all essentially the same. Because we need a way of changing the state of the balance and the wagers and so forth, all of these have the public access specifier. In other words, property methods become the user interface for a way to change the state of this object called the rules object, okay? The wager, that's another one that we want to be able to set. The rest of those are actually property members that are used internally more than anything else, so we don't have any other external public user interface variables for members of this particular class. I talked before about helper methods. Helper methods are those methods that are written just for your purpose. They are not exposed to the outside world. They're just simply there because maybe you have some repetitive task that you're going to do in multiple places in the code, or perhaps there's some special processing that you want to do, but you want to tie it inside the class and not make it available to the outside world. If that's the case, and it is a helper method, it must have the private access specifier because it's not part of the user interface for this class. It's something that's hidden and it's there only for your use. This then kind of gives the person using this an idea of what this particular method is designed to do. Deals out the next 3 cards. It fills in the hand array that was passed in from main. It always arranges the cards so the lower of the first 2 cards is displayed on the left of main. So in other words, this routine takes the 3 cards, looks at them, arranges them in ascending order, and then passes it back to the caller, which in this case is form main. So as you can see here, it helps if you can, let's see, we don't have any tools showing right now, so let's just widen this out. Hand 0 is the low card, 1 is the high card, and 2 is the third card that represents the one that's dealt. What's going on behind the back of the user is that anytime that they press deal, we actually go out and deal 3 cards. The game appears that we've only dealt 2 and we show them to them and then we deal the third one, but that's not the case. We actually deal all 3 at the same time. And indeed, we know beforehand whether this guy's lost or not because we have access to that third card. but we don't display it. So what we're doing here now is trying to decide which card goes where. And this would be for a tie. Otherwise, we have to swap the high and the low cards and then rearrange their indices. These indices are the ones that determine whether it's the high card index or the low card index. Once we get that, we can set and use those indexes to set the cards themselves. So this is a little helper method that's used to just arrange those three cards that have been dealt into their appropriate positions. This is another helper method, and you can tell it's a helper because it's not part of the public interface. It sets the outcome of the bet and tells where to display the down card. In other words, it tells where we want to set the card when it's finally dealt, and it becomes visible to the person playing the game. And here we have comments that say where those positions are. And it's just a series of if statements that compare the low card and the dealt card. The dealt card is the third card. We compare it with the low card, and we also have to compare it with the high card to make sure whether it's in the low or a high range or whether it's a winner. Those are the only two helper methods that we have in here, and those are there for our benefit to make the rest of the calculations in the presentation easier. This gets the first card and treats it as the first displayed card. It calls the My Deck object, and it gets one card. This is the way we determine the low card's index into an array. In other words, by doing a modulo 13, each of the suits in a card deck has 13 cards in it. So by doing a modulo on its number, we know what its value is. So if we have, for example, 26, 26 modulo 13 is 0, that's going to be an ace. 30 modulo 13 is going to be a 4. So we know it's the 4 of something. The king is 13 modulo 13, so it's a special case. So if the modulo value comes out to be 0, we know that it's the king. So the whole purpose of this is to determine where that first card is going to go. The second card does exactly the same thing, and it sets the high card and the high card index. And those were used by those helper methods then to decide where they're going to be displayed, because they're not necessarily dealt in order. We don't necessarily get the low card and then the high card. So we have to do the calculations to figure out where they're going to be positioned. And then we get the dealt card, and we have to do the same calculation for that one to figure out where it fits in the scheme of things. Shuffle deck. We know that we want one of the rules to be if you have less than 3 cards, there's not enough to play the next hand. So we want to be able to shuffle the deck. So our shuffle the deck does nothing more than call the deck's shuffle the deck routine, the deck class. Get cards left. We want to check before we shuffle the deck to see whether we have enough cards to play the hand or not. And this simply calls get cards left in the deck class and tells us how many cards are left in the deck that we're using. Now to deal a hand, we actually just call those methods that we just saw, get first card, get second card, get dealt card, and then set the cards, rearrange them if necessary. And that's what this big long helper method did. Set cards. That's what all of that was doing, was to figure out where those are going to be positioned. And then set winner and position, and we pass in a reference variable to set the outcome. That's going to be responsible for calculating it. That was one of the helper methods that we saw above. And then we had the position, where are we going to show the card that was dealt. It's going to be in one of those 5 positions in those text boxes. And we also have to do a bet covered. Remember, back in Maine, we checked to make sure that they had enough money in their betting pool to cover the bet that they're trying to make. And so we compare the amount that they're betting with the balance that they have. And if it's less than or equal to that, we return 1. Otherwise, they don't have enough money, we return 0. And it's up to Form Maine to decide how to handle that particular situation. Now you'll notice we've gone through this class, and there's no visual components in this class at all. I can't think of any good reason why you would ever want to have a control object from the toolbox appear in a class, unless the class is designed to do nothing else but manipulate visual controls. But as far as the rules or almost any other type of class that you can think about, it's almost always true that you're not going to want to pass in things like text boxes directly, or list boxes, or anything else. As a general rule, that's not a good idea. And the reason that it's not a good idea is simply because if you do that, then you're forcing the user of this class to use the same text box name in the code itself. So try to avoid, you can do something like this .textbox .whatever and get access to form main, but it's not a good idea. So as a general rule, try to keep your classes clean from any user-face elements at all. All you should see in here is the logic that determines the rules of the game, and that's what we're doing here.